Saw blade cutting page produces tangential motion of a disk geometry for a given 2D geometric model. Disk geometry definition comes by tool selection. The tool must be a cylinder. Its diameter and height values should be the same as saw blade diameter and thickness. 2D geometric model selection is called contour selection on this page. A contour is a connected set of 2D geometric elements such as lines, circular arcs, splines, conic arcs, etc. A contour is always on the XY plane of the active coordinate system. Open the saw blade cutting page. You can do this by menu command saw blade cutting under machining. Clicking the same icon on the toolbar will open the page too. You need to select a contour geometry first. If you do not select any geometry, then the last selected set will be used when you press calculate. After you select the contour, you also need to define a start point position for ordering of contour. Be careful. Complete the selection. Otherwise, calculations will be made with previous selections or fail. Contour selection is done by selecting curve objects or solid 2D objects of SolidCNC software. Solid 2D objects can be created from the page's shapes 2D or macro tables. If you import drawings from other CAD systems by DXF or IGES file, curve entities are added. You may also convert curve objects to solid 2D objects. Select your tool. The tool list contains the names of the tools that you have already created. If you do not already have the tool to represent your saw blade disc, add it using the tool dialog page. Enter the part height. This is plate thickness. Enter safe Z value. This must always be bigger than part height. Otherwise, air moves of the saw blade will not be on air. It will be inside the plate. Enter max cutting depth for arcs and lines. Also, define feed rates of circular and linear moves respectively. As you may know, the circular motion of the saw blade inside the plate while cutting is dangerous. Cutting speed and depth values for circular geometry should always be smaller than corresponding linear ones. Feed rate values are used to determine the velocity of the tool functional point on the CNC systems, and they are calibrated to millimeter per minute most of the time. Cutting feed rate is the velocity of the saw blade when its Z coordinate is smaller than part height. In other words, when it is cutting the plate. Entry feed rate is the velocity of the plunge move that starts from a safe position to the initial cutting position. During entry moves, the Z coordinate always decreases. Link feed rate value is for fast moves on air. If a 0 value is given, it is translated as a G00 move code in the post-processor. Exit feed rate value is for retracting moves after a level of single cutting motion is finished. It is common practice to make these moves fast. Spindle value indicates the saw blade revolutions realized in a minute. It is the rotational speed of the saw blade disc. Enter the plunge height value. The plunge height value is a relative value added to the first cutting position Z coordinate. The tool moves to the plunge Z position with a link feed rate speed. Then it slows down to entry feed rate velocity. The plunge height value must be greater than the maximum cutting depth. Otherwise, it will enter into material with link feed rate speed, which is a fast move. Lift-up value is for moving the entire tool trajectory along the Z direction. It is different from the Z overcut parameter. Z overcut parameter moves the tool path along the plunge direction. It will force the saw blade to cut the wood part of your bridge-type machine table. And if bevel cutting is applied, this extra move made by Z overcut is not only along Z direction. It can be an angular move. Lift up is always only along the positive Z direction for positive values. Z overcut is a combined transformation along the negative Z and XY direction. Stock to leave is used to offset the tool path on the XY plane for extra clearance on part walls. You can have a bigger rectangle than you draw by giving positive stock to leave value. You can have a smaller rectangle cut by giving negative stock to leave value. Trimming and extending tool trajectory at the start and end of cutting is possible by using drop list options. The machining side for the tool disc can be reversed if needed. Outer boundary and inner holes need different machining side selections. Taper angle parameters are for bevel cutting. The side walls of the parts may be degrees inclined. Choose a type from the drop-down list. If you have a combination of vertical and inclined side walls, select the taper angle some edges option. Then you need to introduce the edges with angular cuts. It is done by clicking the button to attach the taper value to the edge. Type selection should be selected as a segment for most stone and ceramic cutting applications. The tool rotate CCW option is meaningful if you have